All right, y'all. Hey again. Okay, let's look at what I'm calling 7.4, looking at your main types of enzymes as well as bile. What are we doing here with these helpers, so to speak, with chemical digestion? First type of enzyme we'll hone in on here is a carbohydrase. There are a couple places where we have enzymes that break down carbohydrates. So amylases are produced both in the mouth and the pancreas, which is then secreted into the small intestine, specifically the duodenum, the first portion of the small intestine. So amylases digest starch into smaller sugars. So you can see this is a nice long chain of starches, a starch molecule. We have the connection with amylase, an enzyme that's going to break down starch into smaller glucose molecules. So you got to think back to that Unit 5, all the information on enzymes. Now, also important to note, we have amylase, of course, that's found in the mouth and the small intestine, but maltose is digested by the enzyme maltase into glucose, and it is also found in the small intestine. So amylase and maltose are going to be the ones that you see most commonly, okay? I think it's in maltose. Amylase and maltase. Thank you, guys. Okay. Now we have forms of enzymes that break down proteins. So these would be your proteases or proteases. Now, when we're looking at that, you have your long protein molecule comes in contact somehow with your protein enzyme, the protease, that then breaks that down into amino acids. So when we're looking at types for this, we're going to see that pepsin is the first type that we'll focus on. It is produced in the stomach. Loves to be acidic because it's in the stomach, and we'll hone in on what hydrochloric acid does in the stomach here in just a second. And then trypsin is produced in the pancreas and secreted into the small intestine. It's a little bit higher on the pH scale, doesn't quite like to be as acidic as pepsin. That's why it is better to be found in your small intestine, because it's a more alkaline environment in the small intestine. Okay. So here we go. Next one, lipase. The lipase enzymes are produced in the pancreas and also secreted into the small intestine, and they digest lipids into fatty acids and glycerol. So there's a little review here. You have your lipid, your lipase enzyme. It's going to break down into that 1 glycerol and your 3 fatty acids. Now, for the types of those, you're just going to need to know lipase formed in the pancreas, and it's breaking down fat into glycerol, 3 fatty acid. Okay, let's look at the role of hydrochloric acid really quickly, because this is going to be what's found in the stomach. So the stomach produces several fluids that we call gastric juices. Always fun to talk about that. Love the juices. All right, one of the fluids produced in your gastric juice lineup is hydrochloric acid. This helps kill bacteria and gives a very acidic pH for the enzymes to work in the stomach that they like to be more acidic. So how is a low pH helpful in the stomach? A low pH kills bacteria, and it also is going to help denature the enzymes in those cells. So it's like a first line of defense. Let's say you eat something that might not have had a great, germ or something on it. It can, your stomach can help protect you from some of that bacteria. Not always, because most of us have had some sort of stomach bug where clearly hydrochloric acid didn't do the job, and it's just really unfortunate. But another key aspect to hydrochloric acid would be that pepsin loves a pH around 2. So that's why that hydrochloric acid is going to bring down that pH level to an acidic value that pepsin would thrive in. Okay, now we can move on to bile. Bile is great. It's produced in the liver and stored in the gallbladder. You don't always have to have a gallbladder, but it's great if you do. So bile is produced in the liver, stored in the gallbladder. There's something called a hepatic duct and then a bile duct. So the bile duct connects into the small intestine. We also have the pancreatic duct and the pancreas that comes in through here as well. So they both use this duct to connect into the small intestine. And then bile has 2 main roles. it is an alkaline to neutralize the hydrochloric acid that's coming with that food mixture that's coming out of the stomach. So as you chew, moves down into your stomach, super acidic. Then from your stomach, it's going to hit an area where all that mixture is still very acidic. We need an alkalizer. So the bile is going to be highly alkaline. It's going to kind of chill out what's coming out of the stomach. It's going to raise the pH. And then bile is also going to help break down large drops of fat into smaller ones. We call this process emulsification. Make sure you have that definition written down in your notes. This is where the larger surface area allows lipase to help break down those lipids into the glycerol and fatty acid a little bit easier. Okay. Now, it's important to note that emulsification is the equivalent of like tearing a large piece of paper into smaller ones. It is not a form of, let's see, what does it say? This is an example of mechanical digestion. So it's not chemical. So I know it's happening in your body where we don't like see it physically happening, but emulsification is going to be considered mechanical digestion, not chemical, because you're not breaking bonds. You're simply forming from larger droplets into smaller ones, like you would tear a sheet of paper into smaller pieces. So then chemical digestion can occur more effectively. Okay, we'll pick it up here next round with absorption, and probably I'll move on into assimilation. But go ahead and get your notes down and move on into that CFU. Y'all are doing great, guys.